In the last video, we have reviewed the basic syntax of SQL statements like select, insert, update, and delete. In this video, we'll review SQL queries a little bit more. Again, because everybody already knows SQL, we are not going to cover everything here. We are just going to use some examples to cover some important things that I think you will be using in this class. The example we'll be using is the employees database that we saw last time. And the database looks like this. It has three tables: employees having employee information, and projects having projects information, and project underscore members table has the information about which employees are working on what project. I have created a SQL script here to create this database in a MySQL database. So there are some job table statements at the beginning, and then we create the tables and we insert some data into the tables. So let's head to Adminer, and we'll select this database, and then we will run that script. Okay, right now I don't have any tables. Let's run that script. Okay, now we have three tables. Employees having three records: John, Jen, and Tom. And projects having, so this is projects. Yeah, so projects having three projects, and project members have some project and member association information. Okay, so let's create another script for our SQL queries, and I'll call it queries, why not? And let's start with these examples. Let's make them SQL comments, double dash, space. Okay, let's look at the first query. List the last names of the employees whose IDs are less than 10. By the way, we start with queries that involves only a single table. If we look at the table, everything that we need is in the employees table, and we want the last names of the employees whose ID are less than 10. So the column names are ID, first name, last name, address, and supervisor ID. Okay, so this one will be something like this. We'll say select last name from employees where ID is less than 10. And if we run this in here, it will give us Doe and Smith, which is what we want. This is a very simple query, but I want to use this one to talk about a couple of things. The first is SQL literals. Literals are values like 10 or a certain string like John or something like that. So they are values. And just like Java, there are different types of values or literals in SQL. We have numbers like 10, 30.2. We have strings. In SQL, notice that strings are single-quoted. And if the string has a single quote inside, like Johnny's kitchen, you would use double single quotes, another single quote to escape this single quote. So this will give you Johnny's kitchen with a single quote. And then we have date and time. notice that date and time are basically written as strings in SQL. Both date and time have a fixed format. For date, for example, is 4 digits for year and then dash and then 2 digits for month, another dash and then 2 digits for days. Now, you can use other formats if you have to, but usually database systems recognize this as a default format of dates. So if you write in this format, you don't have to do anything extra. If you use another format like 6/1/2020 or something like that, then chances are you'll need to use some function to convert it into a date type. So just to save yourself some trouble, when you write date type literals, just use the standard or /default format. And then for Boolean, it depends on which DBMS you use. Some DBMS support true and false, and some support 1 and 0. So I think MySQL supports both, but it definitely supports 1 and 0. I'm not actually so sure about true and false. And then there's the special value. Now you can write it as all capital case or all lowercase, doesn't really matter. And this is a special value. So here we have this simple number literal 10, so that's simple. But also notice that there's a operator here, and here are a summary of SQL operators. Many of them are similar to the operators in Java, like addition, subtraction, multiplication, division, modulus, and so on. The ones I highlighted here are the ones that are different from Java. In particular, notice that in Java, we use double equal sign to check for equality, but in SQL, it's just single equals. So for example, if I want to say, find the last name of the employees whose ID is 10, I just use a single equal, not double equal. And for not equal, in Java, it will be exclamation mark, not equal, but in SQL, it's actually this. So it's less than and greater than face to face. And then there are a few additional things. For example, if we want to remove duplicates, right now the results contain duplicates. We can say select distinct last name. And this will remove duplicates. This is how we use distinct. And if we want to order the results in certain way, we can use an order by clause. We can say order by last name. And this will order the results in alphabetic order. Doe and Smith are already in alphabetic order, but if we want, we can say order by descending instead of ascending, the default, and this would order Smith in front of Doe. So order by is now okay. So we'll look at the other ones in a moment. So this is the first query. We've seen some operators, we've seen literals, and we've seen distinct and order by. Okay, so moving on, the second one is find the ID of Jane Doe. So Jendo is here. The ID should be 2. So let's see. We'll say select ID from employees, where first name is Jin. So notice that it's single quoted. And last name is Doe, single equal sign, and AND operator. So if we run this one, we get ID is 2, which is Jendo's ID. And how about this one? Find the names of the employees who do not have a supervisor. So if we look at the table, only John doesn't have a supervisor, and the way to write this query is to check whether supervisor ID column is null. So it will be something like this. We'll say select first name, last name from employees where supervisor ID is null. So this is the most important part, is null. Notice that we are not using not equal to null. We are using is null. This is very important. If we run this, it should give us Rangdong. Now, the reason why there's a separate operator is to check for null is that the null value in SQL is a very special value. It's not equal to anything and it's not equal to anything. It's just a special value indicating something doesn't exist. So if you check for null, always use is, because if you use any comparison operator, it will always give you a false, no matter what. So use is null or use is not null. If you want to check whether something is not null, you say it's not null. If you want to check whether it is null, then use is null. Remember, when you check for null, use the special operator is. And this query by itself is pretty simple, but what if we want to concatenate the first name and last name together instead of showing them as two separate columns? That requires functions. So no matter what database management systems you use, they all provide several categories of functions. Numerical functions, functions deal with numbers like absolute, ceiling, floor, those type of things. And they all provide string functions like concatenation, substring, start with, end with, those type of things. And of course, date and time functions like current date plus 7 days or current time minus 3 hours. And they all provide null related functions to check whether something is null, convert null into like 0 or certain other value, and they all provide aggregation functions, which we'll see in a moment. That aggregate the standard aggregation functions are mean, max, average, sum, and there's one more, count. Yes. So out of all these functions, only the aggregation functions are standardized in SQL standard. All the other functions are DBMS specific. So although all database management systems support the same SQL, when it comes to functions, they all have very different functions. This is the area where DBMS differ a lot. So whenever you use a new database management system, whenever you try to use functions, head to the menu or reference and check which functions this DBMS provides and what what's the syntax of those functions. For MySQL, this is the chapter in the reference manual about functions, and in our case, we want to use the function that concatenates two strings. So head over to the string functions part and look for something that's called concatenate. Okay, here. There are actually two functions. One is called concat, and the other one is called concat_ws. WS stands for with separator. So either one probably would work for us. Concat will concatenate all the strings together, and the concat with separator will ask for a separator, and then the separator will be the first argument, and then you specify the strings you want to concatenate. Okay, so in our case, we probably just need the concat. So we'll say select concat and first name, and then we add a space between, and then last name. So if we do this, this gives us Jando. Now notice that the column heading right now that says concat, first name, last name, and so on. This is not quite a good column heading or column name. And if we want, we can use a so-called column alias, meaning that we can give the column a name. We can say as name and now the column heading is changed to name. So now we have this. This example, two things. First, the use of functions. There's no shortcut. Every DBMS has different functions. So always go to the reference or the menu and check out the syntax. Secondly, there's something called a column alias. You can say as and then a string, and then that one will be used as a column heading in the results. Okay, so these are queries that involve only a single table, pretty straightforward. And then let's look at queries that involve more than one table, which require drawing. So the first one is list the employees who work on the project with ID equals to 1. If we look at the database, we notice that the employees information is in the employees table, and who's working on what project is in the project members table. So in other words, the information we need are in two different tables. We need to somehow combine these two tables and then apply some condition in order to get what we want. And that requires drawing. Anytime if the information is in more than one table, you have to combine them, and that's called drawing. There are several different types of drawings in SQL. The simplest one is called Crossdrawing, also known as Cartesian product. You simply put two tables together, and cross-drawing produce all possible combination of the rows from one table with the rows from the other table. As shown in this example, there are 2 rows in table 1, 3 rows in table 2. If you do a cross-drawing, it will produce a table with all possible combinations, all 6 possible combinations, A1, B1, C1, D1, A1, B1, C1, D2, and so on and so forth. In SQL, if you want to do a cross-drawing / Cartesian product, it's simple. All you need to do is put those two tables together. You'll say select star from employees and project members, and it will give you all possible combinations. Obviously, not all combinations are useful, and cross-drawing is something that you need to avoid using, because not only the results are not often useful, but also it's often that there are lots of results. So if you accidentally do a cross-drawing, it's very easy to overwhelm your database system and slow down all the other operations. So the reason for that is because cross-drawing produces all possible combinations. If you have, for example, 1,000 rows in one table, another 1,000 rows in another table, each table is not that big by itself, but cross-drawing would be 1,000 times 1,000. It will produce 1 million results, and that's quite a lot. And the results are not even useful. So don't do cross-drawings. So what we typically would want to do is something called equal drawing. You can think of equal drawing as a cross-drawing with some additional conditions. So the syntax is similar to a cross-drawing in the sense that you will say select something from these two tables. If you don't have the where clause, it becomes a cross-drawing, but obviously we would want the where clause. And inside the where clause, we have additional conditions so that we can select the ones that we want out of all the possible combinations of the two tables. In this case, we would have something like this. We will say select star from employees, project members, and where employees ID is a project members, member ID, and project members dot project ID is 1, something like this. Well, let's run it first. Unknown column project underscore members. Okay, so that's a misspell. Okay, so now we know that John Doe is the only person who's working on project number 1. Is that the case? Yeah, so project number 1 only has 1 member, project number 2 has 2 members, 3 has only 1 member. Okay. So this is what the query looks like. It's essentially cross-drawing with additional conditions. The additional condition is that the employee ID must match the member ID inside the project members table, and also the project ID must be 1, which is what we want here. So this is known as a equi-drawing syntax, where you specify a cross-drawing syntax but with additional conditions. There are one more thing we can do to make this query simpler. So notice that when we specify a column, when it involves multiple tables, we typically need to specify the table name in front to indicate which column which table this column belongs to. And if the table names are long, it's a lot of typing, and it's easy to make a typo like this. So what we can do is we can use a so-called table alias. We can say from table and then give it an alias E, from project members give it an alias M, and then here we can simply say E.id is M.member ID, and M project ID is 1. And here also we can use the table name or table alias, and instead of selecting everything, we can simply say E.star, only select the employee information in the results. So if we do this, we have the same result, except that it only shows the employee columns. So this one is known as the equi-drawing syntax with a table alias, of course. And similar syntax is inner drawing syntax. Inner drawing is also called drawing, and in inner drawing, we combine two rows, one from each table, if it meets certain drawing condition. In other words, the results will include the matching rows from the two tables. So this is the inner drawing syntax, where we say table 1, inner drawing table 2, on some drawing condition. The drawing condition here is the value in the A column matches the value of the C column. So in other words, there's only one row in table 1 matches one row in table 2. So the result of this inner drawing will be this row. Now if we use inner drawing here, the query will look something like this. We'll say select E.star from employees E, inner drawing project members M, Visual Studio Code always do a autocomplete when I hit enter. On E.id equals to M.member ID, where M.project ID is 1. So if we run this, it gives us the same result. If you compare these two syntax, you can see that they are fundamentally the same. In both cases, we take the drawing of these two tables, then apply two conditions. One is the ID of employee matches member ID, and then the second condition is project ID is 1. So what's the difference? Well, in terms of results, there's no difference. But in terms of syntax, inner ID requires an on clause, meaning that if you use an inner drawing, the database system will force you to have an on clause so that you won't accidentally miss a drawing condition. If you use equi-drawing, it's very easy to miss a drawing condition like that, especially if you're drawing multiple tables, and then you end up with a cross-drawing, which can cause lots of resources, can waste lots of resources in the DBMS. So inner drawing is generally considered a safer way to write drawing queries, because the syntax forces you to explicitly specify the drawing condition of two tables. And if you're drawing more, you have to have more on clause. This way, you won't accidentally miss a condition and waste lots of resources by ending up doing a cross drawing. So technically, these two will give you the same results. In the inner drawing case, you specify the drawing conditions, or you specify the matching columns in the on clause, and then any conditions in the where clause. In the equi-drawing syntax, everything is in the where clause. So the bottom line is that when in doubt, use inner drawing. This one is a safer way to write drawing. Okay, so let's try the other two queries. List the employees who work on the project Blue. Okay, so the employee information is in the employees table. The name Blue is in the projects table, and of course the membership information is in the project members table. So that means this query actually requires 3 table drawings. So let's see how to do that. We will again select the employee information from employees, and we'll also need the other 2 tables. So we'll say projects P and project members M. Come on, Visual Studio Code, where again we need to specify all the matching columns. So employee ID should match m.member ID, and project ID should also match project ID. And one more, the project name. Is it called name? Yes, it's called name. The project name is Blue. Okay. So if we run this query, it gives us John and Jane. So project Blue is project number 2, and if we look at project members, project number 2 has 2 members, John and Jane, so the results are correct. If we do this using the inner drawing syntax, we can do the same thing. Well, same thing in a different syntax. We'll say from employees E, inner drawing projects P on E.id should be, no, not project P. E cannot join projects directly. E has to join project members, because employees and project members have matching columns, no matching columns between employees and projects. So it has to join project members first, and E.id is the member ID. And then we inner drawing another one. This one is projects, and the project ID has to match the project ID in members. And then we specify the additional condition. Project name is Blue. And this should do it. If we run this query here, this gives us the same results. Equi-drawing syntax, inner drawing syntax. And last but not least, find the name of Jindal's supervisor. So this query is a kind of a special query in the sense that if you look at the information we need, Jindal's supervisor's name and Jindal's name, of course, are all in the employees table. However, they are on different rows. Jindal is here, and Jindal's employee is supervisor is here. So in this case, we actually also need to do a drawing, and this one is known as a self-drawing, meaning that we take 2 tables we take the same table and then drawing another copy of the same table. It will look something like this. We'll say select something something, we'll add that in later, from employees E1 and employees again E2, where E1 first name is Jane and E1 last name is Doe, and E1's supervisor ID is E2's ID. Now, if you look at this condition, you can see that we will be selecting E2 because E2 in this case is E1 supervisor and we are looking for Jane supervisor. And if we do this, it will give us John Doe, which is Jane Doe's supervisor. If we want to do this using inner drawing syntax, we can do that. The query is similar. We'll say employees E1 inner drawing, employees E2 on E1's supervisor is E2's ID, where E1 first name, last name are Jane Doe. So same results using inner drawing syntax. This is known as a self-drawing, and a self-drawing is, as I mentioned, what you need if you find out that the information you need is in the same table but in different rows. Then you need to draw in the same table with itself. This will create all the combinations of different rows, and that allows you to apply conditions to select what you need. Okay, so moving on, this one requires something called the AuthorDraw. So find the employees who are not working on any project. Now, if you look at the data we have, it's easy to find employees who are working on some objects because the project members table has all the employees who are working on some project. But what if we want to find the ones who are not working on any project? Well, a simple drawing, equi-drawing, or inner drawing would not do it because all it will do is give us the ones who are working on something. So to find the ones who are not working on anything, we need something called an outer drawing. Outer drawing is basically an inner drawing plus the unmatched rows from one or both drawing tables. What that means is if you do a left outer drawing, for example, also known as a left drawing, then what you end up with are the rows that have matching columns and the ones who don't from the left table. So, for example, here we are doing a table 1, left outer drawing table 2. Notice that table 1 is a left table. The result will have the matching rows, and the matching condition is the value in the A column is the same as the value in the C column. So only this row matches with this row. So this one will be in the result. But because this one is a left outer drawing, it will also include the ones that do not have any matching rows from the left table. And left table here, of course, is table 1. So it will also include this row in the results. And because this one doesn't have anything matching with it, the C and D columns are not. Now, as you would expect, we could also do a right outer drawing, and the results will be the results of an inner drawing plus the 2 rows from the right table with nulls in the other columns. And a full outer drawing, of course, is including the unmatched rows from both tables. This one from the left table and this one from the right table. Okay, so knowing what we know, if we come back to this query, we can see that the way to do this is basically drawing the employees table with the project members table and then find out which employees do not have any matching rows. Let's first do this. Select star from employees E left drawing. So notice that employees is the left table, and we want any ones in the left table who do not have a match in the right table. So we're going to use a left drawing with project members and on e.id is m.member id. So let's see what this one looks like first. So this is what the result looks like. Notice that John and Jane both are working on some projects, so they all have their matching rows in the project members table. However, Tom is not working on anything, so Tom is the additional rows included here with nulls in project ID and member ID because it doesn't have any matching row in project members. So now if we want to find who is not working on anything, all we need to do is do a selection on the result and check which one has a project ID null. So we can simply add where and the project ID is null, and let's select only Tom, or not only Tom. Let's select only the rows from the employees table, and this gives us Tom, who is not working on any project. So this is how we use outer drawings, which is very, very useful if we want to find certain records that do not have matching records in certain other tables. And then let's look at aggregations. Find the number of employees whose last name is Doe. Aggregation means take multiple rows and then aggregate them into a single value. And here we are taking all the employees and aggregate it into a value count, which is the number of records that have the last name, or number of employees who has a last name Doe. And the way to do it is, of course, using a count function and saying count star from employees where last name is Doe. And this gives us the result of 2 because we have John Doe and Jane Doe, of course. So this would be the correct result. Just using aggregation function is pretty easy because there are not many of those, and each one of these aggregation functions has pretty clear meaning. For example, sum will add up all the values, average will take the average value, count will count the number of results or records, and max and min will give us the largest and the smallest value. So all pretty clear. These are the standard aggregation functions, and depending on the DBMS you use, some also give you additional ones, but these are ones that everybody has. Aggregation functions are pretty easy to use. The only thing you need to be careful is when null is involved. Null is quite often in databases. It's not really an error to have null. Oftentimes null simply means the data or the information is not available yet. Later on it may be entered, but oftentimes you can find nulls all over the place. So if we do a max price, for example, the price column has two values plus a null, and is max price 200? Chances are it's probably 200. What about minimum price? Well, minimum price is probably 100. But what about average? Is the average 150? Considering only these two columns, or is it 100, taking all three columns to get into consideration? Well, average is not that obvious. What about UPC? Is it 2 or is it 3? And what about count star? Is it 2 or is it 3? And when you sum up all the quantity, is it 120 or is it null if you add null to 120? So different DBMS actually deals with nulls in slightly different ways. When you have nulls involved, the best way is to just try a few simple examples and make sure you know how your DBMS deal with nulls in aggregations. Here I have a script here that creates a table that's shown here. Let's run that in our database. So, okay, so now we have a new table called inventory, and let's try these things. So we'll say select max price, min price, and average price from inventory. And this gives us 200, 100, and 150. So indeed, the average would skip null and only consider these two. And if we say count UPC and count star, it will give us 2 and 3. Means that if we do a count star, it means counts all the records, it will give us 3. But if we only count UPC, again, it will skip null. And if we do a sum of quantity, it will give us 120. So that means, again, it will skip null. So by doing a few simple queries like this, we know that MySQL will skip null whenever it does aggregation functions, except we'll say count star. Count star means count all the rows or the records. Then, of course, we have 3 records, and none of those records are null by themselves. Okay, so that's about the aggregation functions by themselves. They are not difficult to use. However, when we try to use them in group by queries, they become a little bit harder to use. That's, well, mostly because of the group by queries, not because of the aggregation. aggregation functions. Anyway, let's look at these two queries. So we want to list the number of employees for each project, and then later we can also order the results by number of employees. So the query looks like this. We'll say number of employees for each project. We actually don't need a, do we need a drawing? We actually don't need a drawing, right? This is the number of employees for each project. Okay, if we just need the project ID, we actually don't need a drawing here. So the project members table already give us project ID and then the member working on each project. And we just need to list the ID, project ID, and the number of employees. Okay, so it will be something like this. We'll say select project ID, and then count member, and then from project ID, project members. Yeah, something like that. So this is pretty simple. Oh, we do need to say group by project ID. So this is what it looks like. It will say for the first project, there's one employee working on it. For the second one, there are 2 employees working on it, and the third one has 1 employee. So this is a group by query, and the way to understand group by query is first consider it a 3-step process. When you try to group by something, you have to first get the unaggregated, ungrouped by version. So think of this query as first running this query. Simply select project ID, member ID from project members. And this gives us each project and each member. But this one doesn't do aggregation and group by yet. And then the second step is to group them. And that's where group by comes from. So how do we group these results? Well, we need to specify a grouping attribute using the group by operator. This one says group by ID, so what the system will do is it will get these results and then create groups based on project ID. So if 2 results have the same project ID, they will be put in the same group. So group by will produce 3 groups, first one and second one and third one, each group having the same values inside the grouping attribute. But what do we do with the other attributes? Well, the other attributes are called aggregation attributes, and you are supposed to apply an aggregation function on them to, remember, reduce them into a single value. So here we're applying the count aggregation to these attributes. So this one will produce a count of 2, this one will produce a count of 2, and this one a count of 1, and this one will produce a count of 1. So in other words, the second step is to create groups, and then the third step is to apply the aggregation functions inside each group to produce the result. So this is how we get the final results that shows the count for each project. once again, the way to understand group by is think of the unaggregated, ungrouped results first, and then grouping attributes determine the groups, and the aggregation attributes apply to each group and produce the final results. So here we have the simple version, and then what if we want to order the results by the number of employees? Well, we just add the order by. And here we want to order by the number of employees, which is this column. So we'll say order by that column. And now they are ordered 1, 1, and 2. And list the number of objects each employee works on. So this one would be the same like this one, except that we will be grouping by employee ID rather than project's ID. So this one is easy. I'm going to leave this one as an exercise. But let's add a little bit more here. I want to add a drawing into the mix. I would say show project name instead of ID. So project name, notice that it's in projects table. So we'll have to do a drawing here. And how do we do that? Well, let's do it here. We'll say select something, something. We'll fill this in later. From projects P inner drawing project members M, and we need to specify the drawing condition on p.id is m.project ID, and then we want to do a group by, and since this time we want to show project name, we'll have p.name here, and we need to then group by p.name. And what are we aggregating on? We are still going to count the members. So we are going to say count m.member ID. Something like this. And this one gave us the results. Firestone has 1 member, Blue has 2 members, Star has 1 member. Again, if we want to do order by, we can do order by. So this is another group by query, similar to this one, except this one has a drawing in it, which makes the query slightly more complicated, but the group by and the aggregation part is still the same. Okay, so that's pretty much it for our brief review of SQL queries. There are several important things which we didn't include in the review, specifically subqueries, set operations like union, intersection difference, top N queries like select the top 10 best selling books or top 10 most productive employees and so on. And also very importantly, relational databases support transactions, and we didn't cover or review transactions here. SQL is a pretty important skill. I've known several people who got good paying jobs mainly because they know SQL. So if you have time, take this as an opportunity to brush up on your SQL, whether it's reviewed in this video or not. Review them yourselves. It's a good skill to have for potential future jobs. Okay, This is it for this video. See you in the next one.